involves gain of electrons and oxygen involves loss of electrons. Sure. You have a lot of different types of reactions that go on. This is just one type, but electrons are transferred from one atom to another. Okay, and I'm going to show you one. We're going to get to this in a second. We're going to show you one interesting one that we're going to come back to on the next segment. But this is silver nitrate that I'm pouring in here. Silver nitrate's used for a couple of things. It's used in photography, in developing solutions. It's also used, I think they put silver nitrate in babies' eyes to prevent gonococcal ophthalmal neonatol, something like that. Anyway, so the silver and the copper that's reacting already, as you can see, there's an electronic transfer from the copper to the silver, and you'll see copper ions go into solution, and the silver is going to plate out onto this copper, and it'll look really nifty at the end, but it takes a little bit. So we're going to move on from that to this. Now what this is an electrolysis setup. Okay, and electrolysis is where you take electricity and you cause water to split into hydrogen and oxygen. Normally hydrogen and oxygen like to form water, and it gives off a lot of energy. Okay, and we want to use that for fuel cell technologies, right? That's basically what's happening to fuel cells. You take those electrons that are given off in the redox reaction, and you power things. Okay, in this case, we have to get the hydrogen from something. Okay, if you took all the hydrogen produced in the world in one day, or for a year, it's about equivalent to how much gasoline we use in a day. Okay, really? So if we're going to use fuel cell technology, we're going to have to figure out some way to get this hydrogen in mass production, and the most obvious choice is water. Sure. Okay, so unfortunately we can't get something for nothing. In order to make that reaction go, we have to put power into it, or electricity. So we have electricity going into here, and it's giving electrons to the hydrogen, and it's taking electrons from the oxygen, or from the water, from the oxygen in the water, and we're getting oxygen bubbling up on this side, and we're getting hydrogen bubbling up on this side. And as you can see, the hydrogen is about twice as much as the oxygen, which you would expect because it's H2O, there's twice as much hydrogen as there is oxygen. So that works out pretty good. And if you want, we can...
sure, we got about a minute left here.
All right. We can show that it's hydrogen, because you know I like to burn things.
He's a trained professional, folks, so don't worry.
So this is just a test tube. This should have hydrogen in it. So we'll just... Hopefully I got enough in here to... Now you got to be real quiet here. You should be able to hear a... There we go.
I heard it.
All right, so there's a little bit of hydrogen in there.
There is.
So this is basically, when I was on a submarine, this is how we made oxygen for the submarine. We took water and we split it into hydrogen and oxygen. Really? We pumped the hydrogen off overboard, and we pressurized the oxygen, and this is what we lived on for 3 months.
Okay. Yeah, basically, there you go.
So this is it. This is electrolysis of water.
Very interesting. All right. We'll check back. Oh, it's already starting.
It's already starting here. And if you look over here on this other one, I did this about a half an hour ago, so you can see that. You can see the silver crystals forming on the copper there. And now this is kind of an interesting, there's electronic transfer. It's interesting, but it's not very useful. And on the next segment, I'm going to show how if we separate the two metals, and then we can get a battery.
Oh, great. All right, that'll be coming up. Nice tease there. We'll see you back in 30 minutes. You want to see a replay of this segment, go to our website, illinoishomepage.net. Look on the morning show. Look under Chemist Corner. More from the lab teaching.